Okay, so we'll talk about Docker and Kubernetes and also another technology called Helm. And for each one, we'll do a bit of an overview, talk a little bit about the architecture, but we'll spend most of the time seeing each of these tools in action. So for Docker, we'll talk a bit about the difference between containers and virtual machines, a little bit on the architecture, and some of the key terminology, and then we'll see it demoed. So one of the first things that most people, including myself, had to wrap their heads around when first getting started with Docker is what is the difference between a container and a virtual machine? And really the answer lies in where the abstraction layer lives. So with virtual machines, it's the physical hardware that's being abstracted away so that multiple copies or different operating systems can all run on the same host. And with Docker, it's a level of abstraction higher. And what's really happening here is the containers are sharing host resources. So they're sharing networking and storage and other things, but they get their own very isolated view of those resources. So container A does not know that container B is running, and so on. The best mental model to have here is that containers are basically processes running on your host, not full VMs with full operating systems. So what this means in practice is containers are generally much smaller and start much more quickly than their VM counterparts would. And that's mostly because to start a container, you're not starting up a whole OS and the associated boot process. When we look at the overall Docker architecture, it's relatively straightforward. You interact with Docker with a set of client tools. The primary client tool is what we'll see. It's the Docker command line tool. You can do everything you need to do with Docker with that. There are also some APIs for programmatic use. But the main piece here is in the middle. The Docker daemon, also sometimes called the Docker engine, it knows how to start and stop containers, how to build images, how to pull content from registries and other things. And the good news is these boxes don't imply that these things need to run on different machines. In fact, when you install Docker, most people run with the client and the host on the same machine, or the client and the Docker daemon. And if we dive in a little bit on what that Docker engine or daemon is, at its core, it is the Docker daemon. It's the piece that knows how to do all the stuff I mentioned, but it's wrapped in a REST API, which I said is interesting, and you would only ever need to use that if you were trying to do something programmatic. The main interaction is the command line tool. But it's very easy to get started here. So if you're on Windows or Mac, there's a package called Docker Desktop, which is a pretty simple install. And with that, you get everything you need. You get the Docker command line, you get the Docker engine started up. And recently they've added Kubernetes support. So you can actually start a single node Kubernetes all on your laptop and experiment that way, which is really handy. If you're on Linux, it's a more of a native install process, but also very, very simple. And so there's lots of documentation on the web for how to get started. Some of the key terminology is important to understand. A lot of people get tripped up on the difference between an image and a container, or they use those terms interchangeably. An image is actually the static read-only file that describes how to run a container. So when you're out in places like Docker Hub or registries that store these things, what you're searching for are images. And again, the way to think of them is files. In fact, under the covers, they're files made up of a bunch of layers that build on one another. And because of that, Docker is able to make very good use of caching for speeding up downloads and uploads and other things. But the image is the thing that gets stored in the registry and the thing that you download to run a container. As soon as you start an image, that's when the process gets running on your host, and that is a container. If you get into the business of building your own images, so for example, maybe I want to take a web server, I want to install my web app on it, and I want to package that up as an image, share it with my friends or end users, and let them run it. That is where you use a Docker file. And we'll see a simple Docker file in a bit, but a Docker file is basically a simple text file with a bunch of commands in it saying how to build an image. So the basic workflow is down here on the right. If you're building an image, you start with a Docker file, you run Docker build to build that image. You can then share that image in a registry, or if you want to run it locally, you just run docker run, as we'll see. And then you'll have a running container on your system. Okay, so let's switch over. We'll start to see this in action, and hopefully it'll make even more sense. So one of the things I like to do when demoing Docker to folks that are just getting started is to not try to boil the ocean and just show how quick it is to get up and running and do even non-trivial things with Docker. So here I've got a web application. It is a relatively simple Hello World application, but we are going to run it on a proper web server. In this case, we're choosing Open Liberty. We could have used Tomcat or JBoss or any other app server. But we're going to get all of that up and running in a container on my system with basically a one-line command. The only reason this is 2 lines is because I wanted to make sure it was readable. So I put this path here in a variable, but this could just be a one-line Docker run command to get all of that working. And so I'm going to run this, and then we'll talk about the command line switches because they're important here to understand what's going on. So I'm just going to run this little script I've got that does those 2 things. And if you look in the output, you'll see the first line is, it says unable to find Liberty locally. And that's because Docker, as I mentioned earlier, is very good about caching things. So I started with a completely fresh system here. Obviously, I'm on Windows. So I installed Docker Desktop. And when I run Docker run here, the first thing it does is say, okay, I know that we want to start the Open Liberty or start from the Open Liberty image. So it's looking locally to see if I've ever pulled that image before. And I haven't. So then it went and pulled it from Docker Hub in this case. And my image is already running. And we'll go look at it in a second here. But yeah, I wanted to talk about these command line switches because they're useful. And if you do get started on your own, you'll need to understand them. So this first one here is optional. This gives a name to my container. If I didn't do this, I would get a generated name, and it's a bit tedious to go figure out what that generated name is and then use it in all subsequent command line executions. So if you can remember to give your container a handy name, then future commands will be much easier to run. This next one here, -d, that means run in detached mode. So you might have noticed down here, I got my command prompt back. If I didn't say -d here, I would have seen actually a lot more output. I would have been tied into the container. I would have seen the standard out and standard error logs of Open Liberty as it was starting up. And I wouldn't get my command prompt back because I was effectively attached to the container. I didn't want that in this case, so I just used the -d. If you do run and you're attached, you can always Control-C to get back your command prompt. That doesn't kill the container. It just gets you your command prompt back. This next one is really important, the -p. So basically, if I go out and look at the WebSphere Liberty docs, in fact, on Docker Hub, that's the image I was starting from. As you scroll down, you'll see lots of information, but it'll tell you some things like the fact that by default, the Liberty is going to expose HTTP on port 9080. And that's important. And actually, if I scroll further, I would see the entire Docker run command. So I could have just pasted this in. But what's happening here when I start the Liberty container is Liberty is starting on port 9080 inside its very isolated network. So from outside of that network on my local host here, I could not get to that port unless I run this command, which in -p means publish, or some people think it means port map. But it means publish this port from this image to my local host network, and I can choose any port here, any open port. So I could have chose 9080. I just chose a different one just to show it could be different. So what this means is I'm going to be able to access Open Liberty on what it thinks is port 9080 by accessing port 9082 on my local host in my browser, and we'll do that in a second. And the last piece here is also interesting. I'm doing a volume mount. So I'm saying, take this local web app, which I've got here. It's, as I said, I'm on Windows, so it's actually a folder sitting there. And I'm saying map that folder to a specific path inside the container. So from the container's point of view, it's going to think this is a local folder. And the way this works is, in the case of Liberty, it's always listening for new things being dropped in config drop-ins. So when it starts up and it sees that there's a myapp.war folder there, it'll wake up and actually deploy that application and get it up and running. So as I said, it's actually working here. If I go to localhost 9082 was the port I picked, we'll see Liberty is actually running. And by default, Liberty will use the name of the folder as the app. So I can actually get to my running web application. As I said, it's a simple hello world, but I can get to my running web app this way. So just to point out what's really going on here with that volume mounting, even though the container is running in its own isolated network, just because I specified this part, it's actually pulling in this folder from my main host here, from Windows. So I can actually, in my local editor here, go into my HTML file. I can add some new text, for example. Maybe I'll put in a bunch of garbage characters. I'll save this, and if I go back to my app and refresh, I'll see the updates I just made to my app. So this is a very powerful way for developers to work. If I need to build my web application, for example, I don't want to have a local copy of my web server installed or maybe all the development tools needed, I can do those things in containers and volume mount my source code or my web app in this case, and edit things, and I don't have to start or restart containers. So very, very handy for development. In fact, this is one of the ways that Docker starts to take off in a lot of development teams. Is some developers will see the power and start to really adopt it. Okay, so let's say now that I'm happy with my application. Now I want to package up a new image that's going to include my app inside the container, so that I can share it with my end users and they can just run the image and have my app all built in nicely. So as I said, the way you build an image is with a Docker file. This is about the simplest Docker file you could have. In general, they tend to get a little more complicated than this. You can open up ports and you can set environment variables and do all kinds of things in a Docker file. But in this case, we're just going to do exactly what we did at the command line there. We start with this from directive, which tells Docker start with a base image, in this case Open Liberty and a specific version of it called Web Profile 8. Start from that base image, and this time instead of volume mounting, we're copying that local folder into the container file system. And that's it. And so to build this thing, it's as simple as it can get, really. I'm running a Docker build command. I'll do this from the command line down here. Maybe I'll clear it to get more space. So I'm running Docker build, and I'm saying search in the current folder for the Docker file. If my Docker file was outside in a different folder, I would just provide the full path to it. And then I'm saying tag my image with this tag, and we'll see where that shows up in a second when it's done. So building a Docker image is really easy. In this case, it already had the Open Liberty image downloaded in cache, so it didn't need to re-go get that. And then it just copied my WAR file in, and it's done. So you can see there was 2 steps, and each one generated this new ID, which is interesting. These are called layers. And for example, if I added more things to this later, I would benefit from the fact that there's a base image that already had, for example, my WAR file in it. It can do incremental adds to Docker files, which is really nice. But now I've got my image built. I could put this in an image registry or send it to a end user, and then now they can run it. And actually, I'll change the way I do the Docker run here just to point out a few things. They can now run that image with the same type of Docker run, but now there's no volume mounting because my app is actually built inside the image this time. So I can do Docker run. This time I won't run in detached mode. We'll see what that looks like. I will do a port mapping because I need to access the app. And I'm going to pick 4321 maybe as the port. And it's 9080 inside the container. And then I just give my image name. So if you remember, we called it myapp 1.0.0. And so I'm telling Docker, hey, I want to run this new image and go for it. So this time, because I didn't run in detached mode, you're going to notice from the command prompt here, we're seeing the standard out and standard error from OpenLiberty. I'm effectively attached into that container. And so Liberty's starting up at the moment. At some point, it's going to find that there's a new application. There it is, my app. And yeah, the server's up and running now. So let's see, I chose 4321. So if I go to a browser now and go localhost 4321 my app, there's my application running with those changes I made because I had saved those changes, and so those got bundled into the app. So now I have two versions of this same app running on my machine, both exposed at different ports. So again, this is a very powerful thing from a development point of view. I can have multiple copies of the same application, multiple versions running without polluting the other. And in fact, this comes up a lot when we're building software and have to support an older version of the software for a customer. Being able to stand up an older version and not pollute your system by having to install those dependencies or other things is extremely powerful. So as soon as you've got more than a few things running, you're going to need to understand some of the Docker commands to kind of navigate around and understand what images and containers you have running. So again, if I come back to my command prompt here, you'll notice I don't have my command prompt because I'm attached. I can do a Control-C to get my command prompt back. That did not kill the container. It just broke my attachment to the container. So what I can do now, maybe I'll make this bigger. I can use some Docker commands to see what's going on in my system. So let's start with images. As I said, I started with a completely fresh system here. So I can run Docker images, and this will show me that I have two local images cached, basically. The first one is the OpenLiberty that we've been using as the base image. And we have the new image that I built, the myapp 1.0.0. So those are the only images I have on my system at the moment. If I want to see what containers are running, I do Docker PS. Some folks ask why it's not Docker containers. PS stands for process status. So this is even more indication of really containers or processes running on your host. So if I do Docker PS, I'll see there's actually two containers running, and these are the ones that we've just started. You should see enough information in here to understand what's going on. If you remember the first one that we started, I chose my name, my app, for my container. So I can now interact with that container using that name. For the second run, where I ran the built application, I didn't choose a name, so I got one generated for me, in this case, Naughty Bell. So if I want to do anything else with this container, I either use that generated name or I can use the container ID. So for example, I can start and stop containers very easily. I can do Docker stop my app, and this will stop almost immediately. And when I do a Docker PS again, we'll see it's not running. So it stopped that first one I created. If I want to get it going again, I literally just do a Docker start and it'll start back up. And if I do Docker PS, now it's back again. So really easy to get started that way. If you need to start doing troubleshooting, especially when you start getting into building your own images and running your own containers, Docker provides tons of capability at the command line to do that. I'll show you some examples here. So first things first, let's get a look at the logs. So if I do Docker logs my app, this is going to show me for that container that we've actually started twice now. If you remember, we started at the very beginning, then I stopped it just now and started it again. We're going to see all the logs. So this first set is when it first launched, and the second set is this most recent launch. So you can get the logs really easy that way. Could also do a Docker exec, which is really powerful. You can run commands inside the container and see the results here. So for example, let's say I know that OpenLiberty stores its server configuration in a specific server XML. I can do Docker exec my app And then I can do cat, or show me the contents of config server XML. And this is going to go show me, this is going to basically do that command on the system and show me the output. So this is from the container itself. Even more powerful is I can actually run an interactive shell inside that container. So if I want to log in now to my Liberty container and poke around in Bash or any other shell that is installed there, I can do it like this. I can say docker exec interactive and my app, and I want to run Bash. And this is going to land me in a command prompt where now I'm in the Linux file system. So I can, poke around, and if I could type, I can poke around in here and start seeing what's going on, and all kinds of other things like that. So really easy to do that. And then also, if I ever needed to copy a file out of a container back to my local system, for example, some huge log file or something, there's another command called docker copy, where you can do things like my app config server XML, and I want to copy it locally to server XML. And this should, if I did that right, now in my local system here, I have that server XML copied out of the container. And so this is really helpful when you want to pull things out. So hopefully that made sense. I went through that pretty quickly, but basically you can do things with Docker with just a few commands, and most people are up and running in an hour or less, and starting to understand the concepts. The really exciting thing is that when you go search in Docker Hub, there are all kinds of images there. Most of the tools that development teams use these days, especially the open source ones, will all be in here. One thing we and this is just a point for anyone who starts to promote Docker internally, one thing we do in HCL is, if I search for Java, I'm going to find a whole bunch of stuff in here. Some are going to be tagged like this with official image, and they'll have millions of downloads. But if I scroll down here, maybe I'd have to go to other pages, but there'll be some where they're kind of personal images someone has built. So, this one, whatever this is, has 168 downloads. So a best practice here is you tell your teams to only ever pull official images or images with millions of downloads, with the hope that means they're a little bit more tested or stable. Another approach for this is a lot of companies will not allow any image pulling from Docker Hub. Instead, they stand up their own Docker registry internally, and some team is responsible for vetting images and putting them there. So everyone is only ever pulling from the internal registry, which is actually much, much more safe.